Okay, last lesson we did decimals. Now it's time to move on to fractions. Let's work with adding and subtracting fractions and mixed numbers today. All right, the whole thing when we're adding fractions is that we have to have a common denominator. That is that the denominator has to be the same number. In this case, on example A, we have a 9 and a 9, and on example B, we have a 3 and a 3. So both of these problems, the majority of our tough work is done for us. So when we're adding like fractions, that is common denominators, we just add the numerator, we keep the denominator the same. So the 4 plus the 5 is 9. We have 9 ninths. 9 ninths can be simplified to 1. We always want to simplify. And on B, we're just doing 2 minus 2, subtract the numerators, keep the denominator the same, 3, 0 thirds, that can be simplified to 0. Again, don't forget to simplify. Not always are we going to be able to simplify, but do it if you can. All right, so let's move on to something a little bit more difficult. What happens when we don't have a common denominator? We have 8 and 4. We need to have a common denominator. So what's the least common multiple of 8 and 4? In other words, if I count by 8s and I count by 4s, what's the first number that appears in both lists? That number is 8. So we can turn that 4 into an 8 by multiplying it by 2. But whatever we do to the denominator, we have to do to the numerator. So 1/4 is actually 2/8. It's the same number. Now we have a common denominator. We can add the 1 and the 2, and that's 3/8. And we're done. On example D, what could we use for the common denominator? Okay, maybe we'll get lucky like this one where 6 is a multiple of 2. It is. If we just multiply 2 by 3, we'll get 6. And whatever we do to the denominator, we have to do to the numerator. 5 minus 3 is 2. I can simplify 2/6 to 1/3. One way to look at this is, why are we allowed to do this? We're allowed to do this by the identity property of multiplication. And that states that if you multiply a number by 1, that number maintains its identity. It does not change. Well, 3 over 3 is 1. So 1/2 times 1 is still 1/2. Just looks a little different. All right, these are a little bit tougher because we're going to have to change both of these fractions. Okay, 5 is not a multiple of 2. There's no number that we can multiply 2 by to make it 5. However, we can just come up with another number that both are multiples of. So 10 would work because if we count by 5s, we'll go 5 and then 10. If we count by 2s, 2, 4, 6, 8, 10. So let's turn this into 10 by multiplying it by 2 over 2. Turn this one into a fraction with a denominator of 10 by multiplying it by 5 over 5. Okay, 2 over 2 times 4 over 5 is 8/10. 1/2 times 5 over 5 is 5/10. Now we have a common denominator. We'll add the numerators, and we'll get 13/10. That is simplified, by the way, so that could be our answer. If you want to change it into a mixed number, you can. My general rule of thumb is if you don't have mixed numbers, you don't have to give me. If you don't have the mixed numbers in the original problem, you don't have to give me your answer as a mixed numbers. But if you do have mixed numbers in your original problem, you do need to give me answers as a mixed number. All right, what about 1/3 and 1/4? What number can we turn that 3 and that 4 into so we can get a common denominator like fractions? How about 12? 3, 6, 9, 12. If we count by 4s, 4, 8, 12. So let's multiply the first fraction by 4 over 4. We'll multiply the second fraction by 3 over 3. Not changing their values because we're only multiplying them by 1. That'll give us 4/12 and 3/12. We subtract the numerators. We get 1/12. It's already simplified. Just leave it. All right, what about mixed numbers? Well, with mixed numbers, you've probably been taught in the past to turn them into improper fractions. I'm not going to have you do that. I think it's easier actually if we look at it this way. Just look at the fractional parts, okay? 1/3 and 1/2. Let's turn those into numbers with 6 for the denominator. So let's make this 3 and 2/6 and 2 and 3/6. Multiplied this by 2 over 2 in my head to get 2 6. Multiplied this by 3 over 3 to get 3 6 in my head. And then let's just add the whole numbers. 3 plus 2 is 5, and we'll add the fractions. 2/3 plus 2 6 plus 3 6 is 5 6. And we're done. No problem. All right, what about over here on h? Let's use 6 as our common denominator. Don't have to change the first fraction this time. We'll just leave it 6 and 5, 6. Multiply the 1/3 by 2 over 2, and we'll get 2 6. So 2 and 2 6. Now, we can subtract these whole numbers. 6 minus 2 is 4. And then we'll subtract the numerators. 5 minus 2 is 3. Lastly, simplify the 3 6 to 1/2. Don't forget the whole numbers, though, guys. 4 and 1/2. So we don't need to change these to improper fractions. In fact, that can make it a lot harder because your numerators get so big. Try this. I think you'll like it. All right, let's do this a little bit more. I got to change both these fractions. How about we use 6 as our common denominator? Multiply the first fraction by 3 over 3. Multiply the second fraction by 2 over 2. All right. Then we'll add the whole numbers. We'll get 4. We'll add the numerators. We'll get 7. We can't leave our answer like this. This is a mixed number and it's improper. It's got to be one or the other. Okay? Here's the way I want to look at this. 6 goes into 7 one time. So we need to add 1 to the whole number. It goes from 4 to 5. Okay? 6 goes into 7 one time. That's why we added 1. And how many do you have left over when you do that? 7 minus 6 is 1. So 5 and 1 6. Okay, so if you turn 7 6 into a mixed number, it would be 1 and 1 6. So just add 1 and 1 6 to 4. 5 and 1 6. Okay, on J, let's get a common denominator. We'll use 6. Multiply the first fraction by 2 over 2. And multiply the second fraction by 3 over 3. Now here we got a little bit of an issue. I can do 7 minus 1 is 6, but if I do 2 minus 3, I don't have enough to take away. I'm going to end up with a negative fraction that's kind of weird in the middle of a whole number. So what I'm going to do is I'm going to borrow from my whole number. Instead of 7, I'm going to call that 6. So if I take 1 away from 7, I have to add 1 to my fraction. I'm going to add 6 6 to my fraction. That is adding 1. Okay? So I change 7 and 2 6 to 6 and 8 6. Look at it backwards. Maybe it'll make more sense to you. 6 goes into 8 one time. So add 1 to 6, you'll get 7 with 2 left over. Borrow from the 7 so that you can add 1 or 6 over 6 here. Just add the denominator to the numerator to get your new numerator. Over here, we'll just leave the 1 and 3 6 as 1 and 3 6. Now we can do 6 minus 1 is 5. And 8 minus 3 is also 5. So 5 and 5, 6. Okay, so that's called borrowing. You got to change this 7 and 2 6 to 6 and 8 2 6. 8 6. Still easier, I think, than changing to improper fractions, where you're going to have these big numerators. So in problem H, did we need to rename a whole number to subtract? Let's go back and look at problem H. Did we need to rename a whole number to subtract here in H? No, we didn't. Okay, we can do 5 minus 2 is 3. Whereas in J, we did need to rename the whole number because 2 was less than 3. So let's answer that. The answer is no, we did not need to rename a whole number to subtract. And why is because 1/3 is less than 5 6. So we can subtract without renaming a whole number or without borrowing from the whole number. Nelson wants to replace a piece of door molding across the top of a door. The door frame is 32 1/4 inches wide and is trimmed with molding on each side that is 1 5/8 inches wide. How long does the molding across the top need to be? So we know along the bottom here it's 32 1/4, and we know that each side piece is 1 5/8 inches. So we want to know the whole top. Well, we could do that by adding each piece here. 32 1/4 along the bottom, 1 5/8 along the left side, and 1 5/8 along the right side. Now here, we draw a line there to show the 32 1/4. Then we need to add 1 5/8 here and 1 5/8 here. So let's get a common denominator. 32 1/4, we can rewrite that as 32 2/8. Add up our whole numbers, we get 34. Add up our numerators, we'll get 12. Simplify the 12/8. We could make that, they're both divisible by 4, so how about 3/2? And then we got to change this into a proper mixed number here. 2 goes into 3 one time. So add 1 to the 34, and make it 35. You got 1 left over, so that's your 1/2. So there's addition of fractions in the real world. If the top of a bulletin board is 74 3/4 inches above the floor and the bottom is 38 1/2 inches above the floor, then what is the vertical measure of the bulletin board? We're trying to find this measure right here. We can do that by subtracting the distance from the floor from the distance from the top. So 74 3/4 minus 38 1/2. Got to get a common denominator. Let's change the 38 1/2 to 38 2/4. We don't need to borrow from the whole number because 3/4 is greater than 2/4. 74 minus 38 is 36. So, and 3/4 minus 1/4, or sorry, 2/4 is 1/4. 36 1/4 inch. If you didn't know, this symbol is short for inches. All right. So, adding and subtracting fractions and mixed numbers today. Threw a lot at you, but we'll practice a lot over the coming problem sets. Let's try and do these without a calculator too, and let's show our work on our problem sets without using a calculator. I'll be looking at that very closely. We'll see you tomorrow. Have a great night.